I'm happy to welcome you here at this conference, at this event, and I will lay out options for calculating wind loads in statistics. Thank you. That's very considerate of you. And I will mostly give civil buildings as examples. No frame structures will be taken here into account, although Sophistic has functionality for analyzing wind loads to frame structures, but I will omit that, and I will not talk about bridges because it's a very specific, separated topic. We should have a special separate conference just to discuss that topic. And there are several options of setting up wind loads in Sophistic, manually or via plugin, and most users, unfortunately, not only in Sophistic but in most engineers, just set them up manually. So that's why we leave it on this slide as an option. Since we work and integrate our work with Revit, it makes no sense to go outside of Revit to set the loads. That is why we go this way to set up wind impacts. And next one is a very good module of Sophistic Load wind and dynamic wind. Those are special licenses, and they extend the Sophistic capabilities drastically, especially when we are talking about dynamic wind. And I will talk more about that. And then I will speak about CFD module for laminar, turbulent, turbulent stationary, and turbulent non-stationary modes. And at first, since this conference is about BIM, so I will show you the connection between Revit and Sophistic. The reason why we use it is because we don't have to set up facades, and we don't need to set up elevations, and it's quite easy for up to 150 meters. You can use those tools. Sophistic has such instruments as static and so that's why Sophistic turned into a programming language of a kind, and it's very easy to write plugins and standardize and create algorithms. And what we create in Revit, we can seamlessly transfer to analysis without user participation, and it's not very visible on on this chart, but our templates already have codes for calculate impulses and accelerations. So as a result, we get the needs to strengthen structures, for instance, the foundations, and we get acceleration values. After that, so next, Load. It's a very good module, but you need to define the outside geometrical shells. You have to do that, and it's also useful for cases when the wind load is not constant, but there are areas in the structure of the building that have various, so have different parameters. And the developer has already included many options for wind load calculations. We can calculate dynamic wind for very different spectrums. Well, all the types of winds and loads known in Russia are there. Dolphin is another module for CFD, for computational fluid dynamics. And I would split up working with Dolphin in three very important stages. First, triangulation, because it's very important to get very high quality mesh. And here I mentioned the tools that I and my colleagues use the most. It's Sophie Plus, it's text description in TEDdy. That's not complicated at all. We can use very good it's very good tools for rhinoceros, sophistic for rhino, and can translate data from other mesh processors. Sophie Plus, many who are using it know that, but actually it's in AutoCAD. You said cubes, and here is an example of TEDdy, CAD-in. 200 lines completely describing a large building. That's not much. Going on, a very useful tool is the tool that was added to Rhino. It's a sophistic panel added to rhinoceros, and you can extrude any volumes, any geometry, and triangulate it with high quality results. The very clear mesh, very clear triangulation. Next one. Sometimes it's possible to use third-party preprocessors. There are some very powerful commercial products such as ANSYS, and you can simply transfer the calculation area to sophistic. So it was a very short exercise to check. It's not a real task, just it was just a test to show what is possible. After that, you can set up parameters. Dolphin is a very practical tool, not a study tool. So the user has a limited set of types of turbulence, turbulent flows, and turbulences, and it's good actually because it's very practice-oriented, and you need to select the type of the flow, whether it's laminar or several options of turbulent flows, K omega or K epsilon. It's RNG in sophistic. After that, you need to define the speed of the gas or fluid. In this case, it's gas because we need this gas. And we have certain norms in our building code, ABC. And after that, we use Dolphin for viewing results. You can view aerodynamic coefficients and everything but animation. And so my request to developers, please add this, enhance the capabilities so that we don't have to use third-party animation tools. And here it's a standard tower with turbulent stationary flow with aerodynamic coefficients. And you see that distribution of aerodynamic distribution is completely in line with our norms and with our experience. So as geotechnical people before me were talking, you should verify each tool before using it. You need to verify and be sure that the results will be as needed and as expected. And then a carbon path on the left, and on the right is the same tower, 150 meters, and now effects. So it's a tower in the flows. The deflection of the tower, deflection of high-rise building is one of the major problems for them, and we need to calculate that. Here, on the left, you see the results from the standard sophistic processor. You see which kinds of deviations emerge, and it influences the comfort of people within the building. We use load case 1, wind from the left, wind from the right, and it's quite rare that people use wind from the left, wind from the right, and some at moment. And case number 3, when wind both from the left side and from the front. So we model a deviation from a deflection of the building. And so what is the practical application of sophistic CFD? It's huge, because during the concept stage, you can select optimal placement of the buildings in terms of wind comfort, and during the project, during the design stage, you can use it to submit documents to authorities for approvals, for getting approvals, and you can use mathematic simulation modeling instead of wind channel. And when developing detailed documentation, you can specify wind load, because for a high-rise building, you need to very carefully calculate the strength of glass. And as an example, I'd like to show this project, Avia City, to you. It's a model, it's just shell model in Revit, just facades, just outer shells of the buildings. And you can easily triangulate them and transfer them to get high-quality mesh. This building is triangulated ideally, so this mesh is completely complete squares without any triangles. Some slides are too heavy for this computer, so that's why it takes so long to switch the slides. Here, in this case, we didn't have to consider the wind effects from adjacent buildings because they're not quite tall. And here we considered 8 options, 8 load cases, wind load cases, and that was the design stage. And we want to use those materials for going to the authorities and obtaining approvals instead of organizing wind channel tests. And here you see calculation with wind from the left. Here we visualize the speeds. So it's not ISO fields, ISO lines. So 145 degrees, you see that the system reacts to changing the approach angle of the wind. And here you can see the distribution of the wind masses, and there is a very wide Karman path. We compared CFD analysis to construction codes. They are not called SNPs anymore, but many Russian experts and experts from abroad are used to calling them SNPs. Okay, code checking. And the results was not very satisfactory, but we can explain it, because the higher the building, the less SNP loads are applicable. For this complex, we analyzed comfort for pedestrians, and we calculated several levels. And here are just several examples from real life. It's animation of wind passage between the buildings of this residential area. It was very interesting. We used real experiments in wind channel, and in some point, the discrepancy was not more than 20%. In some 2%, in some 20%. Well, that's good, because we are not sure what the accuracy range of the wind channel experiments are. So here, again, some results for the residential area on Mokomolnaya Street. We have a special construction department, and now we are analyzing this multifunctional building, because we have some doubts regarding these tall buildings, whether they can bear the wind. So that's the stage that it's Wander Park in Moscow. We obtained approvals without wind channel experiments, and my request to developers: Dolphin, add multi-core solver to Dolphin, and in unstructured volume meshes, please add the possibility to build meshes from hexaeders, 3 hexadominant meshes. Any questions to Maxim? Go ahead. Please use the microphone. Wind erosion. What do you mean? Soil erosion. You can calculate the... You can model forces. You can model forces and then solve it. So in buildings, there's not particles that can be freely flown away. And did you have any computations with fluids? Our department asked us to do some calculations for water supply systems. I think we'll do it this year. So we don't have a prize for the most active participant, but I think we shall consider that, and to award this prize to the person asking the most questions. I'm coming from Minsk, and it's a question about norms. So let's imagine, after the construction and commissioning of your buildings, the general layout changes, and some new buildings come into the picture that might influence the behavior. How can you, what can you do to safeguard the situation? According to norms, we do calculations for winds that might occur just once in 50 years. Anyway, you do a calculation for a single building, and because you don't know whether the project will be put on ice and the building will stay with 5 stories and remain in this state for 5 years. So you need to calculate many scenarios and choose the worst case and make the structure strong enough for high-speed flows from adjacent buildings that might be built in future. That's a special story, a special case. But again, I would like to put the emphasis that you choose the worst case and you make your building strong enough and prepare it to that worst case scenario. We so yes, if necessary, we change the configuration of residential buildings in order to avoid high-speed areas where wind just flows with the speed of 30 meters per second. Evgeny Gerasimov and partners, company from St. Petersburg. Transfer of wind pressure to the structure. How does CFD calculate that? I get it. Okay. Inside of those building shells, facades, there is a certain frame, core frame, and I simply redistribute the load. So is it correct to think that those shells, those facade shells, they have certain stiffness and they are connected to the bearing structure of the building? Yes, in a tricky way, but yes. And if you saw, if you paid attention, it really the tower moved depending on the wind, and that's structural analysis task, and not just computational fluid dynamics for calculating the flows of the fluid. So I will be honest, and you at first you cannot do what you want. You need some experience with. Just from out of the box, you cannot solve complicated cases, so just to be open. Now it's easy, but at the very beginning we have to learn a lot and we had to gain experience. And I would like to specify my question. If I get it right, we calculate in certain module here the wind load, and the structures are calculated in another module. It's not quite like that. We remain in sophistics. We remain in that environment. So different modules, but the system is the same. So if I calculated loads in CFD, they can automatically be taken into account in structure analysis, stress analysis software. Sophistic is a database, and just one of the cells or columns of the database have additional data. So these loads are uploaded to the database, and you can use it when you need it. You simply add information to this database when you do the calculations. And here is where I showed it. So it's a structural problem. As you see, this in pure on the left, you see pure CFD, and the cylinder is not moving. But on the right, this is a structural problem. And depending on the flow of the wind, you have this deviation. You mentioned 250 kilogram, 350 kilogram pressure on glass, which height 220 per each square meter. Okay, thank you for this clarification. If you have no further questions, then we are ready to thank Maxim.